So guys, let's start the class. This is day 49, but this is lecture 1 for aircraft structure. GATE Aerospace 2025 batch. Aircraft structure will start from today, tonight, and we'll be having our first lecture. So first I will classify the fashion which we are going to follow for aircraft structure. So we will understand some basic physics. So this basic physics I will cover, like I will give you ideas in different way regarding force, regarding moment, regarding torque, like in different way. And then I will enter into the strength of material. You may have heard this in your college days if you are in aero department or mechanical department, but students who are in electrical CS or other departments, they may not like. This is also known as MOS, mechanics of solid. And then we go for our, after these two we'll go for our core. Now in core of aircraft structure we have almost, like you can say, by including this we will finish our 60% syllabus, and the remaining 40% syllabus we cover here in the core. So in the core, see, there are students, they are confused regarding aircraft structure and aircraft design. Guys, they both are different subjects. In aircraft structure we don't discuss about designs of the aircraft, but whatever designs are already there. For example, if we talk about a design which is going to produce lift, the structural part. So in case of aircraft structure we discuss about already existing structural parts of the aircraft. Structural parts means, you understand, wing, fuselage, landing gear, these things. So we will discuss, for example, what kind of study we will do in core. Suppose this is the aircraft and here we have wing. So here we have wing. So what kind of problem wing has to go through? When this wing is when this wing is producing lift, that time what kind of forces are acting on the wing, what kind of moments are acting on the wing, what kind of stresses this wing, this structural part is going to bear, whatever mechanical whatever mechanical loadings this wing is going to bear. Is it the same in case of fuselage? What is fuselage? In this aircraft structure, this part where passengers, cargo and these things are placed, that section of the aircraft we say as fuselage. So fuselage will experience different types of mechanical loading or same type of mechanical loading. I said mechanical loading, but actually aerodynamic loading is one more cause of mechanical loading. These things you will understand slowly, these technical words. So in our basic physics I will start. Already lot of students will be knowing what I'm going to cover in basic physics, and you will feel greater interest when we'll enter into strength of material and or you can say mechanics of solid. So our GATE syllabus is defined properly for GATE aerospace, but that GATE syllabus is actually different. What I am going to teach you, that will be far more than the GATE syllabus, because aircraft structure is very conceptual subject, okay, and by the student it is considered as the toughest subject of GATE aerospace preparation. So in this aircraft structure I will start everything from very much fundamental. What kind of fundamental level I will tell you. Even if you are not the student of GATE aerospace, you are the CS student or electrical student, I will cover everything from that scratch, that you will not feel any lag, you will not feel any gap, you will not feel that something is missing, you are not aero student so you are not able to cop up. No, you will be doing this properly. So I will just give you some introduction, like what kind of chapters we will cover in strength of material. There is something called elasticity. That will be our largest chapter of this syllabus, of this aircraft propulsion. Elasticity. In elasticity, lot of things we will cover. Some famous parts like Mohr circle is very, very famous in our aircraft structure. Under elasticity. Then we understand our bending part, then we understand our torsion part, then we go for different types of theory of failures, and slowly your syllabus will be very interesting. And if you want to explain aircraft structure in one word, that is going to be stress. Stress means not the student will feel the stress. Stress is a topic. So in every topic, in 70 to 80% syllabus, in the last, we have to calculate the stress. Okay. I mean, whatever structure you will study, why do you study structure? Main thing, what type of loading this structure is going to experience, and because of that loading, structure will fail. So what kind of stress is responsible? So those things we will understand, and this will be more interesting than aircraft propulsion. If you have loved aircraft propulsion during my classes, you are going to enjoy aircraft structure more than propulsion. So let's start in basic physics. So you will classify your aircraft structure unit in 3 different units. One is going to be your basic physics, and another is going to be your strength of material, and then the last one is going to be your core. Okay. So in core, you are going to study your wing structure, your fuselage structure, about landing gears, like these things you will study in core, and different types of stresses experienced by these people. Okay. And strength of material topics are very popular among any type of engineer. I mean, you can be civil engineer, you can be aerospace engineer, you can be mechanical engineer, automobile engineer. Like, I don't know other than mechanical, automobile, and civil and aerospace. These 4 people I know that these 4 people, they study strength of material. Other than these people, I don't know how many people they also study strength of material. I don't think CS or electrical people, they will be studying strength of material in this much detail. Okay, so we are going to start our basic physics. So in basic physics, let's start with very fundamental, very fundamental. There is something called pressure. There is something called force. There is something called moment. There is something called torque. Okay, so let's understand these 4 fundamentals in detail. So pressure we have already discussed properly in our aircraft propulsion. There we have discussed several different types of pressures. We have studied static pressure, dynamic pressure, stagnation pressure, total pressure, hydrostatic pressure, atmospheric pressure, vacuum pressure, positive pressure, negative pressure, suction pressure. Like all these things we have studied, right? In our aircraft propulsion. Okay, one more thing. Here, one thing is also a kind of pressure when you apply physically a pressure on any object. For example, there is a table. On this table, you are keeping any object. Suppose this object is any book. You are keeping a book. I have some fancy diagrams, so I can use this diagram. Suppose I am keeping this book. Now this book will be having certain weight, I mean certain mass. Suppose mass of this object is 10 kg. Okay, now because of the gravity, weight will be experienced, right? So this weight will act downward, that will say 10 G. G value will substitute according to the given data, 9.81 or 10, whatever in SI unit. So 10 G Newton will be your weight. So this time if you will define pressure, that pressure is coming into picture because of the weight. Okay, pressure is equal to force by area. Now when we say area, which area? Area which is in contact with this area. Okay, area of contact. So that area you can calculate, and the force is nothing but the weight. You will substitute here, this pressure you will find out. Now this pressure, out of all these pressures whatever we have discussed in our aircraft propulsion, only one pressure was there which was based on this concept. Can anyone tell me which pressure was based on this concept? You all have done aircraft propulsion with me. Tell me which pressure was based on this concept, like at macroscopic level, which pressure was based on this formula? Can anyone try to recall? Give a try. Hydraulic nahi, hydrostatic.
Hydrostatic pressure.
Very good. It is hydrostatic pressure. Very good. It was hydrostatic pressure. Very good. Very good. Why? Because when we were deriving the formula for hydrostatic pressure rho GH, that time we considered our pressure is equal to weight of the liquid column. That weight was nothing but mass into G, and this mass was nothing but volume into density, and then like this we derived that formula, and then it came as rho GH. Okay, that was hydrostatic pressure. So this kind of mechanical force, currently that mechanical force is your weight, that will give you pressure. You can have lot other examples of the pressure. For example, there is a person, and this person is like standing using these two like shoes. Okay, and weight of the person, some weight will be there, suppose some W weight is there. Now if this area and if this area is same, suppose weight is W and this area is A, this area is A, how much pressure is experienced by this? Suppose this is your right leg, this is your left leg. So leg left pressure, I am asking how much it will be. Can you guys type here, or can you write on my screen? W is the weight. What will be pressure? Okay, just you give me option. Pressure will be 2W by A, 2W by L, sorry, not L, A, 2W by A, W by A, W by 2A, fourth, none. Choose. Which one do you feel? Okay, so okay, good. Some students are choosing option 3, some students are choosing option 2. Very good. So I will explain something, then you will be able to answer. See, we can crack this question with very simple concept. I will tell you. Suppose this is one leg, this is another leg, and I know that there is a weight, this weight is W acting. So you know, this leg will be experiencing reaction force by the earth, correct? So that reaction force will act in this direction. Suppose this is R reaction, this is R reaction, and because the body of the person is symmetrical, completely symmetrical, and in my example the reaction will be symmetrical in that case, so this reaction 2R is going to equal to your weight, correct? So R is going to be your W by 2. So this W by 2 force is acting by on the left leg and on the right leg. Or logically, if you want to understand this, then this W weight will be shared by both the legs. This W weight will be shared by both the legs, half. So how much mechanical force? W by 2 mechanical force. W by 2 mechanical force is experienced by like, what is the area I have given you? Area is A. So W by 2 force divided by area. This will be the value of pressure experienced by each leg. Okay, so this third option is correct option. Students who are thinking W by A, I hope you understood my explanation. Now let's go for, so you understand. Now we'll go in more detail about the force. So because pressure concept we have already dealt here in the aircraft propulsion, and here what kind of pressure you are going to discuss, that is going to be a proper mechanical pressure that will be applied using hand or using any tool or something. Okay, it will be visible properly that someone is applying pressure on something. So that's why I'm directly going to the force now. So we'll enter into the definition of force. What is force? So you may have this idea in your childhood. What was the force? Force has a proper definition. Force has a proper definition. So see, in two ways you can explain what is a force. One is like mathematical way you can use rate of change of momentum. Rate of change of momentum, that is force. Or there is another way, logically, force is that physical quantity which can change the state of inertia. You understand what I'm saying? State of inertia. Force is something which in physics, in science, which has capacity to change the state of inertia. What do I mean? Imagine something is kept on rest, okay, so this guy will always be in rest for lifetime, for infinite time, until and unless there is any external force is not applied. So if you'll apply any external force, it is not necessary that this force is going to bring this object in motion. It is not necessary. It may. Okay. So that's why when we define force, force is that thing which may change the state of inertia or certainly change. We are not sure. So object was in rest. Rest is one state of inertia. When you will understand inertia in your basic classes, school days, we classify, some teachers classify inertia in two ways: inertia of rest, inertia of motion. And in some schools, some teachers, they add one third one, inertia of rotation, right? If something is rotating, even that guy you can stop from rotation, or if something is stationary, you can make that thing to rotate. So rotation is also kind of motion. So that's why some people, I mean some teachers, they don't classify separately, they just consider that also under motion. Anyway, that is not a big deal. You understand, inertia is something like that is a state. Okay, for example, currently I am teaching, you are listening my lecture, I am teaching, so I am maintaining a state of inertia. Okay, what is inertia? Inertia is kind of habit, you can say. Like, not exactly, don't take this, I'm explaining in very loose way, not very so let's understand what it. Suppose I'm wearing this glass right now. Some people are wearing watches, some people are wearing rings in their fingers, some people are wearing earrings in their ear, okay, and some people they nose ring in their nose, some people wear cap on their head. So sometimes when you will remove these items, then also you may feel that that item is present there. Okay, so that state of mind is not changing. State of mind is still maintaining that, okay, you have the cap, I have the ring, I have the glass on my face. Okay, something like this. I will tell you one more example of inertia. We all are doing toothbrush in the morning. Okay, so we have a proper pattern. Suppose by mistake, suppose this is the face, and by mistake somewhere here you got a cut and you don't have pain, and morning you forgot that there is a cut. So you will wash your face in same way, the way you are washing regularly. Okay, when the water and the soap bubble, something will go there, then it will like you will feel something irritation something there, then you'll, oh yeah, there was a cut. This is called inertia. Okay, so in physics, broadly we have classified inertia as a rest, inertia as a motion, like inertia of rest, inertia of motion. So whatever body you have, that body will be either in rest or in motion. Currently, right now, suppose I am sitting here in my room, so this is inertia of rest. I will not move from this place. Either I should apply a force or any someone else should apply force on me. So that is concept of inertia of rest. Just inertia of motion. If something is already in motion, if you want to change this state, then you have to apply force. If you will apply something, I am saying something, that something is force. When you apply force, then it is not mandatory that this force will work. I mean that this force will stop the object. It may stop, correct? It may not stop, but it will try to stop for sure. Now, how will you explain about rotation? That is also very good thing. If you want to how will you explain rotation? So suppose something is rotating in this direction. So you want to change its direction. So again, you have to apply force. Best example is aircraft. Okay, suppose we have aircraft, and aircraft is going in this direction, and you want this aircraft to go in this direction. In that case, there is something called rudder. Okay, rudder is one of the control surface. We use this at here, vertical tail. On vertical tail we use rudder. So you will deflect rudder in this direction and in this direction, in both directions. According to that, aircraft will change its path. This kind of motion, when aircraft go left and right, that we say yaw. Okay, left side yaw, right side yaw. So here we are playing with the direction. Okay, so I was explaining about this What is force? So force is something which is going to change your state of rest or state of motion or state of direction. So that is a physical way to explain force. Mathematical way to explain force is nothing but rate of change of momentum per second. Rate of change of momentum per second. What is momentum? Momentum is nothing but mass into velocity. Okay, so see, momentum P is nothing but multiplication of mass into velocity. So this mass may change, may not change, this velocity may change, may not change, but if momentum is changing, any one has to change for sure. Okay, for example, there is a wall and ball is striking on the wall and coming in this direction. So in this example we consider that velocity is changing, mass is not changing. But there can be a good example where mass is also changing. For example, rocket. Okay, in case of rocket, suppose your rocket is going in this direction, so it is maintaining, suppose, certain velocity v. Every second it is maintaining velocity v. Suppose every second it is maintaining same velocity. So in this case, if you check about momentum formula, momentum is mass into velocity. So velocity is not being changed, but every time gases are coming out, so this rocket is being light because mass is decreasing every second. So every second mass is changing. So this is best example to explain velocity is not changing but momentum is changing. How? Rocket is very good example to explain this. Okay, now there can be another example. Let's understand, when you talk about force, you have to talk about momentum, and when you talk about momentum, you talk about mass and velocity. When you talk about velocity, then you have to talk about speed and direction. Okay, so speed means, suppose there is a car and this car is going in this direction with the speed of 10 meter per second. So this 10 meter per second is a speed. Okay, this data has nothing to do with the direction. But if speed and direction means same direction, suppose this is I direction in mathematics. So if it is always maintaining I direction, then velocity is not changing, because to change the velocity, speed and direction both should change. If any one, I mean to say any one must change. Any one must change. Example, if you throw the ball upward, suppose this is J direction, mathematically Y direction upward. This time when you throw the ball free hand, you throw and then you leave, then ball goes up. This time speed is decreasing but direction is not changing. So overall velocity is changing, of course velocity is changing. In this example, the 10 meter per second, if you are throwing in the beginning, then 9, 8, 7, blah 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 blah, and 0. At maximum height it will be 0. But one more example, suppose you have any ceiling, and with this ceiling you have something this kind of thing, and you are rotating like this, and you are rotating like this, and suppose this is run by any battery system. So every time your speed is 10 meter per second, speed is not decreasing, but you can see every time its direction is changing, right? Every time direction is changing. So velocity is changing or not? Yes, velocity is changing. So in both examples, what did you understand? In this example, direction is not changing, magnitude of the velocity, that is nothing but speed, is changing. In this example, speed, which is magnitude, is not changing but direction is changing. It means you understood that both or anyone can be responsible to change the velocity. Now I'll give you one more example. Suppose you have this to and fro motion, okay, of the pendulum. Take the pendulum in this direction and then you leave. Then after some time, pendulum will come to the rest. So this is the best example where speed and direction both are changing. Both are changing. Okay. So now idea is, we started for the force. Then we understood that, okay, force has to do something with momentum. Now momentum has to do something with velocity. Now velocity means speed and direction. We understood this list completely. Okay. Now when velocity is changing, then momentum will change. So we go for the formula F is equal to change in momentum. So suppose final momentum P2, initial momentum P1, and to change the momentum you have consumed some time T. Okay, you replace these values like m into final velocity minus m into initial velocity, mv mu, divide by time, take m common, so it is now v by u by t. And you see, you remember there was three equations of motion. The first equation was v is equal to u plus at. From this equation find out value of a, so v minus u by t. So I can replace this, so this formula will become f is equal to ma, very popular formula, right? And this formula comes from this definition, this definition. Rate of change of momentum is called force, and mathematically that is the meaning of force. Physically I explained, force has this capacity. Force is the property by virtue of which you can change the state of inertia of any object. Okay, F is equal to ma, clear. Now let's understand. Now we are going to discuss what do you mean by moment. Don't be confused with momentum. Okay, momentum is P, formula is m into v. Now I'm talking moment. Moment symbol is capital M. Now moment, what is moment? So see, moment is like, see, right now I am not at all bothering about scalar quantities, vector quantities. Okay, I will bring that also into the concept, into the explanation. But already I have made a very beautiful video regarding scalar and vector quantities. After the lecture, you guys do one thing, just go to YouTube, and because I have given you physical meaning of scalar and vector quantities, like physical feel. So just type scalar and vector quantities, ConceptLibrary, Viru Sir, something like this you type on YouTube, and you'll be getting some quantities. I have explained why time is scalar, why temperature is scalar. Okay, these things. Why force is not scalar, I have explained properly. You will have physical feel. You will go to more basics of this. So momentum is anyway vector quantity. So, and that is a different discussion, how a quantity becomes a vector. If I have two quantities, if I multiply them, that will be vector or a scalar. Those things are different logic. These things you will understand when I'll be teaching you engineering mathematics. Okay, I'm erasing. I have to talk about momentum, and with momentum I have to talk about torque. So these two properties I have to explain. What do you mean by momentum? What do you mean by torque? So imagine this is any wall. In this wall there is a door. This is door, and you want to open the door. So this is the handle. Here you are applying any force F. So what will happen? This door will turn like that, and the door will open. So here, which physical phenomena, which physical property is responsible for this? So that physical property we say moment. Moment is that physical property which can rotate or which can bend something. Okay, suppose this is rigid. Suppose this is rigid. In that case, this will bend, right? This will bend in that case. But suppose this is not rigid, it is hinged. Hinged means at this position you have some, and at this position you have some, and here you have completely gap. So this guy will rotate. So moment is nothing but about which axis this door is rotating. So about this axis. About this axis door is rotating. So from that axis, what is the smallest distance of the force? That distance considered as r. So if you multiply these two properties, this r and this f, then you will be getting moment. Now again there is a question. You should, because see, r is also a vector quantity, that is position vector. Why do we say position vector? Because when you apply the force here, this point has a specific position with respect to this. So that's why that point has a position vector. That position vector is r. So now you know, you may have heard this, when you do multiplication of two vectors, then if you are doing, like, suppose vector A is there and vector B is there, when you are going to multiply them, then you should know, you should go for, you will go for scalar product or you will go for vector product. Okay, and if you are going for vector product, then A cross B and B cross A, they will not be same thing. They will be different in direction. They will be different in direction. So currently, if I say that you have to multiply R and F, this F you have to multiply with the R. So R cross F will be the right answer, or F cross R will be the right answer. So these things are the part of mathematics, because in mathematics you feel that. Of course, this is the part of physics also, no doubt. So these things are basic physical weakness. you don't feel them because you don't understand them, it means you are weak here. So to cover these things, I have already designed bridge course. Okay, bridge course. So all the students are already having access of my drive course. In the drive course, I have given a folder for the bridge course. I will show you just a moment. Where is bridge course? Let me open the drive, then I will share the screen. Okay, now I am sharing the screen. Guys, is my screen visible? Anyone?
Yes, sir.
Okay. So now see, I'm going to the folder concept library. The first is bridge course. In bridge course, you have class notes, you have DPP, and you have video lectures. Okay, you have to watch these video lectures, and after that you have to solve DPP. DPP means daily practice problems. So you have to solve all these things, and you will be very comfortable with lot of things. And these are the class notes. Anyway, class notes are not important for you, because when you will watch these video lectures, you will make your own class notes. Okay, so that was the idea for the moment. But when you discuss about torque, torque is completely different than moment. Okay, how torque is different from moment? Because to create torque, you should have equal and opposite forces. Two forces must be there. Example, when you want to open the cap of the bottle, so suppose this is the neck of the bottle and this is the bottle body, and here you have any cap. So to open the cap, one force you will apply in this direction and one force you will apply in this direction, and this is the axis of rotation about that this cap will rotate. So it means what? This is the point about this is the axis. Suppose it is perpendicular to the screen, and at certain distance you have force in this direction, at certain distance you have force in this direction. So you can find out torque. Okay, so to find out torque, you can take any one force. Suppose this force is F, this force is F, equal and opposite. So any one force and the gap between both. Any one force, gap between both. Torque symbol, you can, there are so many symbols, tau, capital T, whatever is suitable. So these are basic physics, right? So this is the difference. Now let's understand when we say, oh sorry, when we say that there is a very good example I am giving you. Suppose there is any box. On this box you are applying, let me raise this. So we understood basics of force. We were working on this, that there is a bottle, there is a neck, and you have some cap in this. So apply one force in this direction, one force in this direction. So equal and opposite forces will produce torque. But to produce moment, you don't have to use two forces. Only one force is sufficient. Very best example what you are going to face in future. Suppose there is any point here, any wall here, and you have any beam here. I used a name beam. What is beam? I will explain you in coming lectures. What is beam? What is shaft? What is rod? What is column? What is tie? What is strut? These things I will explain one by one in coming lectures. So suppose you are applying any force. So you are applying one force. So this will bend this guy like this. Okay. So here you will experience moment. Okay. Now one more example of torque. Suppose you have a circular shaft like this. Okay. And this part is inbuilt in any wall, completely fixed in any wall. So apply one force here, apply one force here. So it will start rotating like this. Okay, so you are creating twist because of torque. That is also known as, this phenomenon is known as torsion. So these things we'll see in upcoming lectures in detail. So you know, by applying linear force you can produce rotation. How? So for that only I drew this body. Imagine one force is here, 10 Newton force, and one force is here, 10 Newton force. So if I ask what is the summation of the forces, then you will say 0. Why? Because any one of these forces you will consider positive and another one will be negative. So suppose this is positive, then automatically this will be negative because of direction. So if you add 10 Newton and minus 10 Newton, it will be 0. So force is 0, but but torque is not 0. Why? Because with respect to this origin, this guy will start rotating like this. Okay, so force is 0, but still torque is there. So we saw these very basic ideas. Now let's understand one very fundamental thing, that is called work. Which work? What we are going to discuss because of force. Okay, so before entering into the work, I will just give you one very easy glimpse of a scalar product. Suppose you have two vectors, vector A and vector B, and you are doing dot product. Then this is called a scalar product. Dot product is called a scalar product. It will give you answer as a scalar quantity. Okay, so imagine I'm talking about the work. So work is nothing but force and dot product with displacement. You know what very good thing with a scalar product? This A dot B or B dot A, they both are same thing. Means you can also write B dot A, but you cannot write same thing for cross products. In case of dot products or scalar products, they are exactly same thing. So when you open this vector product, it gives you f d cos theta. So this is the real value, the real formula of the work done by using this force. Okay, what is d, what is theta, I'll explain here. So imagine that there is a road, and on this road you have any object, and this object mass is m is equal to suppose 10 kg, and object weight is acting downward. This is equal to 10 into 10 is your gravity, so total 100 Newton. And imagine you are applying in this direction any force. This force is 20 Newton from horizontal. This angle is suppose 30 degree. Okay, and you applied this force on this object, then this object shifted in this direction and reached here. Okay, so consider that this object has traveled 45 meter. Okay, so in this direction I can ask you two questions: work done because of force F, work done because of weight. These two questions I can ask. Okay, so I have not given you data in terms of vector quantity. I mean, I have not given you force like this. Force is equal to 2I plus 3J Newton. This kind of data I have not given you. I have directly given you the magnitude of the force. So if you talk about WF, work done because of F force, that is F is 20 Newton. So you'll apply 20 into how much displacement? 45 into what is cos theta? Now here is a trick, just wait. Now when you talk about W because of the weight, then what is weight? 100 Newton. And what is distance? 45 into cos theta. Just wait. How to discuss theta? So to discuss theta, theta is the angle between the vector force and the vector displacement. Remember, when two vectors are attached to their tail, then only that theta is correct theta. Or when two vectors are attached with their head, then only that theta is correct theta. If the vectors are not connected in this fashion, then angle theta is not theta. For example, if one vector is here and another vector is here, and I'm giving you this theta as a 120 degree, then this theta is not the right theta. This is not the angle between two vectors. Why? Because only these two are considered. So in that case, what will you do? You know, any vector will not change if you are not changing its length and direction. So you do one thing. This vector you take from here and you draw here. So length did not change, direction did not change. So now tail and tail of both the vectors are matching. So now this angle is the right angle between two vectors. Okay, what will be that angle? So 180 minus 120 is कितना हुआ ये? 60 हुआ. ठीक है, 60 degree. You can do one more change. This vector you can remove from here and you can draw here. Okay, in that case also you did not change direction, you did not change length of the vector. So this angle is your right angle because head and head they are touching each other. So if this is 60, this will be 60. So in same way, in our case, now what will be angle between displacement vector and the force vector in my question? How will you judge that angle? Okay, so you can clearly see in which direction I'm applying force. My force is applied in this direction, and which angle is given? Angle from the horizontal is given as 30 degree. In which direction you have displacement? Displacement is in this direction, so you draw displacement arrow like this. Okay, so is this 30 angle is valid for us or not? Directly can I substitute cos 30 here or not? Can I substitute cos 30 there, guys, or I should substitute some other angle? What do you think? Yes, cos 30 I can substitute there. So cos 30 value is root 3 by 2. Okay, root 3 by 2. So W, because of the applied force F, is nothing but ये कितना हो गया 20 into 45 900 हुआ, और cos 30 कितना हुआ root 3 by 2. So उसको solve कर दो, that will be your answer. Okay, now you think about this much, 100 into 45 into that cos theta. Here how much theta you will apply? So remember, this is tricky problem but very easy problem. How it is easy? See, which force we are targeting now? You, whenever you calculate work, always the force is very properly specified. You cannot find out work done for any force. You must mention which force you are asking. So in the same problem, I have discussed two different forces. One force was applied force, one force is the weight of the body. So always remember, work done by the weight of the body is always zero. Work done by the weight of the body is always zero. What is the logic? Logic is motion is in this direction and weight is always acting downward. Total angle is how much? 90 degree, and cos 90 is how much? 0. So you substitute here cos 90. So answer is 0. But same problem if I will make such that body is going downward in the earth, in that case work done will not be 0 because of the weight. Because weight and displacement, they will be in same direction. Let's solve one problem, what I'm saying. I hope this concept is also clear. So 100 into 45 into 0 will be 0. So suppose I'm giving you, now one more thing. In the same problem, I can also frame one problem in the same question, which is based on frictional force. You know that in sliding condition, in basic physics, I hope you remember that much physics, your friction will work in this direction. Okay, and how do you calculate frictional force? To calculate friction force, formula is mu into R. What is mu? Frictional coefficient. So I have not given you frictional coefficient in this problem, but suppose it is 0.1. Frictional coefficient is suppose 0.1. So frictional force is 0.1 into R is your reaction force. Some people remember this formula as mu into N. N is normal reaction. So same normal reaction I am representing as reaction R. So in this case, reaction R will be upward, reaction R. Okay, so this reaction R and this mu, if you multiply, I mean, what is R value here? Whatever is the weight, that will be your R. So R is weight is 100 Newton. So substitute 100 here. So 0.1 into 100 is 10. So 10 Newton became your frictional force. But frictional force is acting in which direction? In opposite direction, in this direction. And your displacement is in which direction? In this direction, in this direction. Angle between two vectors 180 degree. 180 degree. मतलब क्या हुआ? मतलब हुआ कि work done because of small f, that is friction force, is nothing but 10 Newton friction force into 45 meter displacement into angle कितना है? Cos 180 degree. This guy is -1. So work done is -450 Newton. Clear? Now here's the question. Work done is scalar quantity. So what do you mean by this negative answer? This is a very good problem in interview. They ask in interview. So this is that work done, what is done by the engine to overcome the friction, force. This is that work done. Okay, this much work means you can say this much energy is lost to overcome the friction of 10 Newton. That is the physical meaning. Okay, so I will give you one problem. Just try to solve this problem. This is the parachute, and with this parachute someone is flying. So mass of the person is 100 kg. Consider g is equal to 10 meter per second square, and air drag is there. So the air drag, because of the air drag, the upward force was experienced 5 Newton. You tell me. I will ask you three questions. I will ask you a question like this: work done because of weight, work done because of air drag. These two questions I will ask. Now I can also ask work done because of resultant force. Three questions I can ask. So work done because of weight is nothing but weight into displacement, and this time into cos theta, right? Weight into displacement cos theta. Weight is nothing but mass into gravity. So 100 into 10, this became your weight, and displacement. So this displacement I have to specify. So suppose they are falling to this height. I mean, they are falling to this from here to here. Suppose this height I am giving you 70 meter. Okay, so this is your 70, and cos value will be cos 0. Do you understand why cos 0? Because weight is a vector quantity, that direction is downward, and motion is also downward. So cos 0 value is 1. So it is simple 7 with 1, 2, 3, 4 zeros. Okay, means 70k joule, something like this. Okay, 70k, if you are not able to understand, just write 70 with 3 zeros. This much with SI unit. Everything is in SI unit. Okay, now because of air drag, if you find out, then in that case minus sign will come, because air drag is upward, displacement is downward, theta is 180, cos 180 is minus. So force is 5, and total drop was 70 meter, and into minus 1. So whatever answer will come with minus this thing. Okay, next. Negative sign will come in the answer. How will you explain the negative sign? This much work done, we are losing this much energy. Why? Because this air drag is not allowing us to fall freely. This air drag is not allowing us to fall freely. Okay, next, about this thing, resultant force. That is very easy. How much force is downward? Weight is downward. How much force is upward? Minus 5 is upward. So W minus 5. W is nothing but 1000. So 1000 minus 5, 995. 995 you multiply with the 45. That will be your final answer. I hope this part is clear. This is how we calculate work done. Okay. One tricky problem. Question is, this is the object, and I am applying 10 Newton force from this direction, 10 Newton force from this direction. Case 1. Case 2, I am applying 10 Newton force in this direction and 10 Newton force from the horizontal 45 degree in this direction. Okay, you have to calculate. In this case, work done because of final resultant force is how much, and in this case, work done because of final resultant is how much. Okay, so these two answers you will post in WhatsApp group. Okay, this is your case A answer. You will write as answer A, and whatever is your answer, then you will write answer B, whatever is your answer. Okay, I am asking because of final, and I will also give you data. So if there is a displacement, just consider that displacement as D. I am not giving you numerical displacement. Means your answer will contain D in the answer. Okay, displacement I am giving as D. If this question is clear, tick on my screen if question is clear, because I will not explain this question here. Okay, question is clear. Then tonight or before tomorrow class, we have class tomorrow. lecture 2 for aircraft structure. We'll be dealing with basics, because once you guys are good in basics, then we'll slowly enter into the strength of material from the basics. Okay, that's all for tonight. I will stop the recordings. You guys can stay with me and ask your doubts. I'm stopping the recording.